Imagine standing at the edge of the world's most unforgiving landscape. The wind cuts through you like a blade. The sand stretches endlessly in every direction. No trees, no grass, no water. Just an ocean of golden dunes shifting beneath your feet, swallowing everything in their path: roads, farms, entire villages. For decades, this was the reality facing millions of people living on the fringes of China's great deserts. The land was dying, and it seemed like nothing, no human effort, no government program, no amount of willpower, could stop it. But then something remarkable happened. A quiet revolution began. Not with tanks or warships, not with political speeches or international summits. It began with robots, thousands of them, marching into the sand, drilling holes, planting seedlings, and slowly, methodically, doing what many scientists once said was impossible. They started turning the desert green. Welcome to HEMS Reports. I'm Mike. And today, we're telling the story of one of the most ambitious environmental engineering projects in human history: China's war against desertification, and the extraordinary robot army that may have just changed the outcome of that war forever. To truly understand how significant this achievement is, we first need to go back. Back to a time when China wasn't winning this fight, when the desert was, in fact, winning. Before the turn of the 21st century, China was facing an environmental emergency that most of the world barely knew about. Desertification, the process by which fertile land gradually transforms into desert due to drought, deforestation, and poor land management, had spread its grip across an enormous portion of Chinese territory. According to government surveys conducted in the late 1990s and early 2000s, China's desertified land had ballooned to an almost incomprehensible 2.61 million square kilometers. Let that number sink in for a moment. That's roughly 1/3 of China's entire national land area. Gone, barren, unproductive, and in many cases, actively dangerous. Think about what 1/3 of a country's land turning to desert actually means in human terms. It means farmers watching their fields disappear under sand. It means communities being forced to relocate, not because of war or politics, but because the earth beneath their homes was literally blowing away. It means roads buried under dunes overnight, rivers running dry, and livestock dying from lack of pasture. It is, in every measurable sense, a slow-motion catastrophe. And at the center of all this, the most feared, the most powerful, the most relentless force driving China's desertification crisis was one desert in particular: the Taklamakan. Even the name carries weight. In the ancient Uyghur language, Taklamakan is widely believed to mean you go in, but you don't come out. Others translate it simply as the desert of no return. Either way, the message is clear. This is not a place that welcomes visitors. Stretching across 330,000 square kilometers in the heart of China's Xinjiang region, the Taklamakan Desert is roughly the same size as the entire nation of Japan. But unlike Japan, with its lush forests and crowded cities, the Taklamakan offers almost nothing. No reliable water sources. Temperatures that swing from scorching summer highs above 40 degrees Celsius to brutal winter lows well below freezing. And wind, ferocious, relentless wind that can erase a landscape overnight. But what makes the Taklamakan truly unique, and truly terrifying from an environmental standpoint, is that it is classified as the world's second largest shifting desert. This isn't a static landscape of fixed dunes and settled sand. This is a living, moving, breathing beast of a desert. Its dunes don't sit still. They migrate. They shift. Some of the larger dunes can travel dozens of meters in a single night when strong winds blow across the basin. And those dunes are not small. The tallest sand dunes in the Taklamakan reach heights of more than 200 meters, roughly equivalent to a 100-story skyscraper made entirely of sand. When one of those giants starts moving, it moves with the force and indifference of a glacier. Slow enough that you don't always notice immediately. Fast enough that, over a season, entire agricultural regions can simply vanish beneath it. For the communities living around the Taklamakan, and there are millions of them, this isn't abstract geography. It's a daily lived reality. Dust storms blanketing cities hundreds of kilometers away. Sand creeping into irrigation canals and rendering them useless. Transportation corridors, roads and rail lines that connect remote communities to the broader world, constantly threatened by encroaching dunes. This was the challenge China had to confront. And in the beginning, the tools at their disposal were startlingly basic. China didn't wait for robots or satellites or artificial intelligence to start fighting back against desertification. Long before any of those technologies existed, China mobilized one of the most powerful resources it had always had in abundance: its people. As far back as the latter decades of the 20th century, the Chinese government launched what would become one of the largest ecological restoration projects ever conceived. Known as the Three Norths Shelter Belt Program, sometimes called the Green Great Wall by international observers, this initiative was designed to build a massive living barrier of trees and vegetation stretching across the northern, northeastern, and northwestern regions of China, effectively creating a green shield against the advancing desert. The scale of this human effort was staggering. At its peak, nearly 200,000 workers were deployed to battle desertification on the front lines. The Chinese military was also called in to support ecological construction efforts in some of the most remote and difficult desert zones. These weren't comfortable assignments. The desert doesn't care about political directives or national pride. It is indifferent to human effort. Working in extreme heat, biting cold, and constant dust, these workers were fighting an enemy that seemed, at times, impossible to beat. Their methods, by modern standards, were almost heartbreakingly simple. One of the most widely used techniques was the grass square method, a labor-intensive process in which workers would take bundles of dried straw and bury them in a grid pattern across the surface of the desert. Each bundle would be pushed roughly 15 to 20 centimeters into the sand, with about 20 centimeters left sticking above the surface. This created a physical barrier that reduced the wind speed at ground level and stopped the sand from moving quite so freely. It wasn't a permanent solution, but it worked well enough to buy time for seedlings to take root. Alongside this, Chinese scientists worked tirelessly to develop specialized plant varieties that could survive in the brutal conditions of desert regions. Normal trees and shrubs, the kind you'd find in temperate forests, simply couldn't survive the dryness, the heat, the poor soil, and the sandblasting winds. But through years of agricultural research, China developed and identified species that were extraordinarily drought-resistant, plants that had evolved to find moisture in places where most life would give up. These plants were cultivated in nurseries, transported to desert regions, and planted by hand, hundreds of millions of them, one seedling at a time. By 2010, after more than 4 decades of continuous effort, China's afforestation program had successfully greened more than 100 million mu of formerly desertified land. That's a number worth pausing on. 100 million mu, an area larger than many entire countries. And it was achieved almost entirely through the force of human hands. But the costs, both financial and human, were enormous. Here's a truth that, honestly, doesn't get talked about enough in the celebratory stories about China's greening efforts. This work was brutally hard, and it was expensive. Overwhelmingly, punishingly expensive. Let's start with the human cost. The desert areas where anti-desertification work needed to happen were, almost by definition, the most remote and inaccessible parts of China. Getting workers to these locations required long, difficult journeys. Keeping them supplied with food, water, and equipment in environments where temperatures could be lethal required enormous logistical operations. And even once workers were on site and ready to work, the physical limits of human performance meant that a single worker could typically lay only about 300 square meters of grass squares in a single day. In a desert spanning hundreds of thousands of square kilometers, that's a deeply humbling rate of progress. Then there's the financial dimension. The economics of desert reclamation at scale are genuinely daunting. Consider just a few of the numbers. The cost of saplings and water supply alone for desert planting runs to approximately $210 per acre. Add to that the labor cost, roughly $100 per acre, and you're looking at a minimum of $310 per acre just to put a tree in the ground. Multiply that across the millions of acres that needed treatment across China's desertified regions, and the total cost reaches figures that really strain the imagination. For context, controlling just 1/3 of China's total desertified land area using traditional manual methods would require what experts described as astronomical levels of capital investment. Money that, no matter how committed a government might be, has real limits. And beyond cost, there was simply the practical reality of what human workers could and couldn't do. People get tired, people get sick, people can't work through a sandstorm at 3 in the morning. People can't operate effectively in extreme heat day after day without rest. There are fundamental biological limitations to how much a human workforce can achieve, no matter how many people you deploy and no matter how determined they are. China understood this. And so, in the early 2020s, Chinese engineers and robotics specialists began asking a fundamental question: what if machines could do what humans couldn't? The year was 2021. In a stretch of remote desert in northwestern China, engineers from a consortium of robotics companies and government research institutions gathered to test something that, even a decade earlier, would have seemed like science fiction. They had built a robot designed specifically to plant trees in the desert. Not a robot that could assist human workers, not a machine that could carry equipment from one place to another. A fully autonomous, artificially intelligent robotic system that could analyze the terrain, identify suitable planting sites, drill holes in the sand, inject water, insert seedlings, and move on to the next location, all without a human hand guiding it. The initial experiments were encouraging enough that China's government gave the green light for rapid expansion of the program. Engineers went back to their workshops. Scientists refined the technology. New specialized models were developed for different terrain types and different stages of the planning process, and the production lines started running. By 2025, the results of that commitment were visible in a way that no one could dispute. A fleet of 8,000 sand control robots had been deployed across China's desert regions, contributing to a total afforestation area under the Three Norths project that had reached an extraordinary 480 million acres. 8,000 robots. Let that image sit with you for a moment. 8,000 machines working in coordinated groups, navigating shifting sands, drilling through hardened desert crusts, planting seedlings with a precision and speed that no human crew could match, all in service of one of the most ambitious ecological restoration missions ever undertaken. But how exactly do these machines work? What makes them so remarkably effective in conditions that have historically broken human-led efforts? These are not simple machines. They are some of the most sophisticated pieces of field robotics ever deployed in an environmental application anywhere in the world. And honestly, understanding how they work helps explain why they've been so transformative. Let's start with how they're organized. China's desert robots don't operate as lone units wandering the dunes independently. They work in coordinated clusters, using what engineers call cluster local joint control technology. Every 5 robots form a working group. Within that group, each unit has a specific role, and they communicate constantly with each other to coordinate their movements and tasks. This collaborative approach means that a single group of 5 robots can complete the tree planting work for approximately 180 acres of desert in a single day. Think about that number. 180 acres per day per 5 robot team. Compared to the old benchmark of a three-person human crew completing just 2 acres per day, this represents an improvement in productivity that is almost too dramatic to fully process. We're talking about a productivity increase of roughly 90 times per unit of human or machine involvement. Now, let's look at what happens when a robot group arrives at a planting site. The process begins with the lead robot, a powerful drilling unit powered by a dedicated engine. This machine bores a hole into the desert floor that goes approximately 1 meter deep. In dry, compacted desert soil, this is no trivial task. But the drilling robot accomplishes it in a very short amount of time, creating a planting hole that reaches down to the depth where moisture and stability can give a seedling its best chance of survival. Once the hole is prepared, the other robots in the group take over. Water is injected into the hole to create an initial moisture environment around the root zone. Then a seedling is placed, with precision, into the hole, positioned at exactly the right angle and depth to maximize its chances of establishing a stable root system. The entire planting process, from the moment the drilling begins to the moment the seedling is secured, takes approximately 20 minutes per acre. And within that acre, 160 individual seedlings are planted. Do the math, that works out to 1 new tree being planted in the desert roughly every 10 seconds. 1 tree every 10 seconds. That is the pace at which China is rebuilding its deserts. Speed alone wouldn't be impressive if the trees didn't survive. Planting a tree and watching it die a few weeks later from dehydration or sand burial accomplishes nothing. The true measure of a desert restoration program isn't how many trees you plant, it's how many trees survive. This is where the intelligence built into China's desert robots becomes truly significant. Each robot in the fleet is equipped with an artificial intelligence-powered visual analysis system. Through a combination of cameras, sensors, and sophisticated machine learning algorithms, these systems can survey the surrounding terrain in real time and make complex judgments about where tree planting is most likely to succeed. They can identify areas where soil moisture is marginally higher, where natural topography might provide a little shelter from prevailing winds, or where the sand composition is more conducive to root establishment. Using this analysis, the robots automatically calculate the most efficient planting route. Navigating around obstacles like dune crests and dry gullies, optimizing their path to minimize time wasted while maximizing the number of productive planting sites visited. No human navigator could match this kind of real-time, data-driven terrain assessment across a shifting desert environment. But there's another critical piece of technology that deserves special attention: irrigation-free seedling technology. Traditional tree planting in desert environments required enormous quantities of water, a resource that is, by definition, extremely scarce in deserts. Water had to be trucked in, often over long distances, at significant expense. And even then, early-stage trees were vulnerable to drying out between watering sessions. China's desert robots use a more sophisticated approach. By combining precision placement with seedling varieties specifically adapted to retain moisture in their root zone, and by delivering a carefully calculated amount of water directly into the planting hole at the moment of installation, the system dramatically reduces the total water needed while simultaneously improving the survival rate of each planted tree. The outcome is, honestly, remarkable. Trees planted by these robot systems achieve survival rates of between 70 and 80%. In the brutal conditions of the Taklamakan and other Chinese deserts, that figure was once considered essentially unachievable. Earlier manual planting operations frequently saw survival rates far below this, sometimes as low as 30 or 40% in the harshest environments. The combination of precision planting, optimized site selection, and moisture management has nearly doubled the effectiveness of every seedling that goes into the ground. The robots are also designed to physically endure the environments they work in. Their bodies are built from hardened, durable materials, capable of withstanding the sand-blasting effect of desert winds. Each unit has its own integrated cooling system to manage the extreme heat. Their power systems are designed for continuous operation. These machines can work 24 hours a day in conditions that would force any human crew to stop and take shelter. They can operate on flat desert plains. They can handle slopes of up to 25 degrees, navigating uneven terrain where dunes create significant gradient challenges. For more demanding slopes up to 12 degrees, they can even perform stable planting operations without risk of slipping or tipping. One of the most powerful arguments for the robot-led approach to desert reclamation isn't just environmental, it's economic. And the numbers make a compelling case. A standard small-scale sand control machine, the kind used widely across China's desert restoration operations, costs roughly 30,000 Chinese yuan. At current exchange rates, that's approximately 4,000 to 4,500 US dollars. By contrast, hiring, transporting, housing, and maintaining a human workforce to accomplish the same work over the same period costs dramatically more, both in direct expenses and in indirect costs, like healthcare, safety equipment, and the logistical infrastructure required to support people in remote desert conditions. But the economic case goes beyond just cost per unit of work done. When you factor in efficiency gains, the picture becomes even more compelling. As we've already established, mechanized planting is more than 10 times faster than manual methods. This means that a given restoration target can be reached in a fraction of the time, which matters enormously in the context of a desert that is continuously shifting and expanding. Speed is not merely convenient. In the war against desertification, speed is strategic. Beyond speed, the mechanized approach also reduces the overall cost of sand control and stabilization by more than 40% compared to traditional labor-intensive methods. This isn't a marginal saving, it's a structural transformation in the economics of ecological restoration. Projects that were once financially unviable because of their cost become achievable. Areas of desert that were too remote or too harsh to justify manual intervention become candidates for machine-led restoration. The human testimony on this point is vivid. Local tree planting workers who have watched the transformation firsthand have spoken about the contrast in striking terms. One worker described how, in the old days, a team of 3 people working together could manage the tree planting for about 2 acres of land in a full day's work. Today, with the new self-propelled grass grid sand barrier equipment, one of the specialized machines developed as part of China's mechanization drive, a single operator can complete the grass grid suppression work for 20 full acres in that same day. One person, one machine, 10 times the output of 3 people working by hand. These aren't just statistics, they represent a fundamental shift in what's possible when human ambition is amplified by the right technology. Now we arrive at the milestone that triggered much of the global attention that China's desert program has received in recent months. Because in the closing weeks of 2024, something historic happened. The green barrier around the Taklamakan Desert, that audacious project of wrapping one of the world's most hostile landscapes in a ring of living vegetation, was completed. The journey to this point had been long. By the end of 2023, the green barrier had already stretched to an impressive 2,761 kilometers. But there were still gaps, sections where the chain of vegetation hadn't yet linked up, where the desert remained open and unguarded along its flanks. Engineers and ecologists had identified these gaps, and the deployment of robot teams and human crews to fill them had become a priority. Then, in the final months of 2024, the last gap closed. The final section of vegetation was established, and for the first time in history, a continuous green chain of 3,046 kilometers encircled the entire Taklamakan Desert. Every edge, every flank, every previously open section where sand could freely escape and spread. Locked in, contained, surrounded by living plant life. Chinese forestry officials described this achievement using an evocative phrase. the full realization of locking edge closure for the Taklamakan Green Sand Barrier Project. In other words, the desert had been ringed, sealed, and contained. It was no longer free to expand in any direction without encountering a living barrier. Satellite imagery from American remote sensing systems, independent verification that carries its own significance, confirmed what Chinese ground teams were reporting. The images showed, unmistakably, a continuous green line tracing the edges of the Taklamakan. It had become, by any objective measure, the longest green ecological barrier surrounding a desert anywhere on Earth. The achievement drew comparisons, not unreasonably, to some of the great engineering feats of human civilization. Like the original Great Wall, built to keep physical invaders out, this green wall had been built to keep a different kind of invader in, and it had succeeded. But the story doesn't begin and end with one desert, no matter how dramatic the Taklamakan narrative might be. China's anti-desertification efforts have produced a transformation that extends across the entire country, and the cumulative scale of what has been achieved is staggering. According to data from China's Forestry and Land Management departments, the Three Norths project area has now completed a total of 480 million mu of afforestation across its operational zones. That's not a typo. 480 million mu of land that was once bare, degraded, or at risk of desertification, now supporting tree cover and vegetation. Alongside this, the program has also managed and restored 1.28 billion mu of degraded grassland, a separate but equally vital component of China's ecological recovery. Grasslands in China's northern and western regions had suffered enormously from overgrazing, climate stress, and the same drying trends that were driving desert expansion. Restoring them was essential not just for ecology, but for the hundreds of millions of people whose livelihoods depended on healthy rangeland. The human dimension of this transformation is perhaps best captured in a phrase that Chinese environmental officials have used to describe the scale of change.